Okay, in this lecture we're going to talk about radical notation. In the previous section we talked about the way we use exponents and using rational exponents. Well, there's a direct link between these two. When we talk about the square root of a number, this is really the number of the power of a half. Okay, because we showed in general that if I took a to the n and then we took it to the power of n, this was equal to a to the 1, which was a. So a is the nth root of a to the 1 on n. And so consequently, if I have the nth root of a, we can talk to this about the same as a to the 1 over n. Okay? And then, of course, if I have the nth root of a to the m, okay, which of course is also the nth root of a to the power of m, this is a to the m over n. Right, so we're going to deal with this kind of notation because we're talking about this being the nth root of a to the power of m. Okay, we're talking about this being the nth root of a. Okay, right. So if we were talking about the square root, we're actually talking about the square root of a, and so we're looking for a number, okay, that when multiplied by together gives a. Right, so let's do some examples here. All right, and we're going to write each root using exponents. So just get some practice changing from radicals. A radical is any expression that has a root sign with it. Right, so let's have a look here. For example, if I have the cube root of 64, that means I'm looking for 64 to the power of 4, which means I'm looking for a number, to the power of 3. We're looking for a number when multiplied by itself 3 times gives us 64, and of course this would be 4. Okay. Part B, we could do the fourth root of 16. This would be 16 to the quarter, a number multiplied by itself 4 times to give 16, and that would be 2. Alright, over here let's look at part C. Let's suppose I want the negative fourth root, negative of the fourth root of 10,000. This means I'm looking for the negative of the 10,000 to the power of a quarter, which of course is going to be negative 10. Right, the fourth root of 10,000 will be 10, and so consequently we'll get negative 10 for this. The negative sign stays there. So what if we want the fourth root of negative 81? Well, of course this is going to be equal to negative 81 to the quarter, and we already know that since 4 is an even number, we can't have a negative here, and so this is not a real number. Okay, part E. Right, let's suppose we want to find the cube root of a rational, so let's say 125 over 512. Then we're looking for 125 over 512, the third root of that. Alright, so this will be the third root of 125 and the third root of 512. And of course this will be 5, alright, over 8. Okay. Alright, if we look at next one, let's suppose I want to find the negative fifth root of 243. Alright, so that's the negative of the fifth root. Okay, so this is the negative of 243 to the fifth power. So this will be negative 3. Alright, now this would be different to if I wanted to find the negative of the negative 243. Alright, and let's make it the fifth root of that. Okay, so that's a little different. So this is going to be negative of the negative 243 to the 1/5, which of course is going to be the negative of negative 3, which would be 3. Right, so now let's go to let's look at sums that involve fractions which are not necessarily 1 over something. So let's look at examples of this. Right, again, we're going to write the radical, right, form for, okay, here we go. Let's suppose we have 8 to the 2/3. Alright, so this will be 8 to the 1/3 squared, which of course is the cube root of 8 squared. Okay. Alright, so of course we know that this would be 2 to the 2, which would be 4. Okay. Alright, let's look at the next one. Let's suppose we want negative 64 to the 2/3. Well, this would be negative 64, the cube root of it, squared. So this would become, the cube root of negative 64 would be negative 4 squared, which will be 16. What if we want negative 121 to the 3/2? Now notice that the 3/2 is only applied to the 121, so this will be the negative of the square root of 121 cubed. Now we don't really need the 2 there, alright, because if there's no number there we assume it's the square root, so this will be the negative of the square root of 121 is 11 cubed, okay, which will be negative 131. Right, now we can do it with not just numbers, we can rewrite things if we have a variable. What if I have the 7x to the 2/3? Alright, now the 7 is not affected by this, so this will be 7 by the cube root of x squared. Okay. Alright, what if we have, let's do part E here. Let's suppose that I have 16 q, or yeah, let's q to the negative 1/5. This would be 16 over the 5th root of q. Alright, and of course we could have a binomial. Let's suppose we have 5x minus 3y to the 1/7. This would be the 7th root of 5x take 3y. Make sure the radical sign goes across the whole lot of it. Alright, so that's how we do that. And we can also do some examples of writing in exponential form. Okay, exponential form. Alright, so let's do part A. Let's suppose I have something like the 6th root of n to the 5. This would be n to the 5/6. Right, let's do part B. Let's suppose I have the cube root of 5x. This would be 5x to the 1/3. Okay, part C. Let's suppose that I have 15, the cube root of r, all the power of 4. This would be, the 15 is not affected, so it's 15 by r to the 4/3. If we look at the next one, let's suppose I have -3, fifth root of 3b squared, and let's suppose this is to the power of 4. The -3 doesn't matter, so this will be the fifth, well, let's do it the fifth root. So look in here, so it's going to be 3 to the 4 by b to the 8. Okay, so this will in fact be -3 by 3 to the, this will be 4/5 by b to the 8/5. Right, now of course this is 3 to the 1 here, so it'll be a negative. 3 to 1 is 5, so that'd be 9 on 5, 3 to the 9/5 by b to the 8/5. Okay. Alright, and finally, what if we have the fifth root of x squared plus y to the 4. This would of course be x squared plus y to the 4, all raised to the 1/5 power. Okay, so that's how we do conversions between radicals and exponents.